Okay, today I'm going to talk to you about velocity time graphs. I'm going to show you a few features of a velocity time graph, and I'm going to show you how to calculate the total distance travelled. So what I'm going to do to begin with is I'm just going to draw some lines on here, and then in a minute we'll discuss what they actually mean. So let's have something that looks like this. Okay, so this is just tracking the journey of a moving object. Now, on a velocity time graph, we have time on the x-axis. This is exactly the same on a distance time graph. We always have time on the x-axis. The big difference is between a velocity time graph and a distance time graph is we have velocity instead of distance on the y-axis. Remember, velocity is basically how fast an object is travelling. Remember, velocity and speed are very similar. The only difference is velocity is a vector quantity and speed is a scalar quantity. So, first of all, let's think about what these mean. Now, if we have a straight line going upwards like this on a velocity time graph, it means we have acceleration, meaning the object is getting faster. That's because if we look at after 1 second, the object is travelling at 1 meters per second. At 2 seconds, it's now faster, it's travelling at 2 meters per second. And after 3 seconds, all the way up here, it's travelling at about 5 meters per second. So it's getting faster, it's accelerating. Also, it's good to notice at the very beginning, because the velocity right at the beginning was 0 meters per second, that shows, if ever the line is here, it shows the object is stationary, is not moving. Okay, next up. Now, if we have a horizontal line on a velocity time graph like this, this is showing it's moving at a constant speed. Now we can tell this because at 3 seconds it's moving at 5 meters per second, at 4 seconds it's still travelling at 5 meters per second, and at 5 seconds it's still travelling at 5 meters per second. So for this portion of the graph here, it just stays travelling at 5 meters per second, meaning it's travelling at a constant speed. Now finally, if we have this part here, a line going down, it means we have deceleration. That just means it's getting slower, it's slowing down, because at the top part here, it's travelling at 5 meters per second, but over time it's getting velocity is getting less and less, which means it's getting slower and slower until we get down to here at 0 meters per second, which means the object is stationary. So it's a little reminder, this object accelerated, started moving at a constant speed, then slowed down, it decelerated. Now, we can actually use a velocity time graph in order to find the total distance travelled. Because this object has been moving, we can actually use our speed equals distance over time equation to find the distance that this object's moved. So if we're trying to find the total distance, we need to do speed times time, or in this case, velocity times time. And by doing that, we need to find the area underneath the lines, underneath this part of the graph. So first of all, we're going to have to split it into different sections so we can find the area of these different shapes. So first of all, let's do it for the first portion of the graph here. So to find the area of this section here, it's a triangle. So to find the area of a triangle, we need to do half times base, which on here is 3 seconds, times height, which is 5 seconds. So 3 times 5 seconds. So 3 times 5 is 15. Half of 15 is 7.5 meters. You could use a calculator for this, but for this video, I'm just going to do them in my head. Okay, so 7.5 meters. So after this portion of the graph here, the object has travelled 7.5 meters. So what I'm going to do next is I'm going to look at this next portion of the graph. I'm going to break it down into smaller chunks so I can find the area of each of these different shapes. This time we've got a rectangle. To find the area of a rectangle is really nice and easy. It's just base times height. Now be careful, because I've got to find this is my measurement here for my base, not all the way from here. So it's between 3 and 6. So it's 1, 2, 3 meters in total. So I'm going to do 3 times my height, which is 5. So that is 15 meters. So the final thing I need to do is I need to find my area for this section of the graph, where we're decelerating, we're slowing down. Again, I've got to find the area of a triangle. So to find the area of a triangle, I do half times base, so it's between 6 and 10 seconds, so 1, 2, 3, 4. So times height, and my height here is 5. So 4 times 5 is 20, half of 20 is 10 meters. So all I need to do to finish off is I need to just add these together, because at this portion I've travelled 7.5 meters, at this portion of the graph I've travelled 15 meters, and at this portion of the graph I've travelled 10 meters. So my grand total, that's 25, so that's going to be 32.5 meters I've travelled in total. So that is how to use a velocity time graph. Thank you very much.